Welcome guys. I'm gonna concentrate in today's video on header and an end unit. That's actually pretty important, especially for somebody that's new. We're gonna create a new program. Actually, my bad. We're gonna call the program 1. We're gonna go with Mazatrol program. So this is the beginning how you create a program. Okay, now you have options: cast, duct, CBN, alloy, stainless, aluminum. What these actually things do is the machine by default has some pre-programmed or predetermined speeds and feeds for certain materials. I never use it because I always make the adjustments. Small parts, big parts, you have good holding, bad holding, whatever you want to call it. These things usually don't apply. But in case if there's a company that actually does it, I'll explain to you what that actually is. I usually go with stainless. Now, OD Max over here, which is the first one, it says max outer diameter of workpiece. I'm going to explain to you what later the difference. Why would you go with close to the material size, or let's say if you have a 2-inch part, why would you call it 6 inches? ID, I put always 0 no matter what. Length, we'll call it 6 inches. Work face, so it says length, workpiece length. We have work face, let me see it. Stock removal of work face, right? Let's call it 0.200,000, and maximum RPM, let's call it 1200. End unit. So I always do this. When I create my program, I put headers, end unit. Ask to continue. Continue, yes, 1, 0, no. If this is only one piece, or you're doing one piece at a time, we don't want to continue. This is where you want to stop. Parts counter, you want to count or no. If you do a lot of parts, you can put as yes, 1, but if you only have a couple of parts and I don't want it, return tool change position or 0 position. Tool change position, machine will track to the longest tool plus let's say 70,000 or 40,000, depends on the size of the machine. Arbitrary position, you can set that yourself. So I usually go tool change position, then it rotates or clears. Work number, next workpiece. This is if you're jumping from one program to another. You can have 2 programs for the same part. I don't do it because if you watch my previous programs, if I have a second part, what I do is I use an end, okay, over here, and then you can do a shift or you can make adjustments to the program. The easiest way is to create program 1, program 2, because in program 2 you can change your Z position. That's usually it's the case, and so on. So you do flip first part, you flip the part, you do the second time on the second program. Second program, let's say next program would be 2. On your second program, if you want to go back to the first one, just use a work number. You can go to the tool file and pretty much pick whatever number you have. Now, if you have a multiple, let's say rings or whatever from a bar, and let's say you're going to continue. So we call it, we have a bar like this, and you do 6 rings. So you go continue 1, repeat times of the same program. Let's call it 6 rings. We're gonna call 6 times. Your rings are 1/4 inch. You shift a 1/4 inch. So that means it's gonna go 1, shift, 2, shift, 3, shift. Each shift is gonna be 250,000. Obviously, this is just a exemplary number. But you make the adjustments to if you're cutting off the part and whatnot to shift accordingly. Parts counter, same thing, tool change. So technically, this is a header. Now, when it comes to when we're talking about the stainless steel material, if you go to the position page, you shift with the left soft key, you're gonna see COND. Okay, so these are cutting conditions, I presume. And you're gonna come out with the page like this. You have work material, okay. So as you see, we have stainless steel. And over here you also have two materials, so you have your boring bars, end mills, face mill, and stuff like that. This is where you go to second tab, okay, which is let me see, cutting speeds. And as you see, you have drills, for example, type of drills you use, or if it's inserts, right? Now, and these are your cutting speeds, so these are going to be your for example, you have a carbide and you're doing stainless steel, it's going to go 177. This is your where you put your feed rates. Same thing, stainless, it depends what insert you use or what material do you use. Then you have your percentages, you have your recipe speed and feeds and cut depth, tool material percentages. This is for your turning. Same thing, turning, if it's a bar out, bar face, corners, threads and everything. This is where you find all the adjustments, your loads and specs, spec cutting force. So common and tapping. Okay, so over here you can make changes. Like I said, also on the bottom you have tabs. So whichever page you do want to see, cut, condition, learn. This is pretty much end mill, carbide, depth of Z, processes, roughing, finishes. I don't, like I said, I don't touch it. Technically, I just use my experience to adjust my feeds and speeds to the type of the parts that I do, because usually, like I said, you'll jump from small parts to big parts and whatnot, and but the averages technically are going to be similar. And let me give you an example how these things work. So we'll do okay, turning, bar out 6 inches. We're gonna go a little bit lower. Finish 10,000. Finish on a Z 3,000. You see pattern, and as you see, max depth of cut. Okay, so as one, and I'm gonna pick what do we use? CBN input coating carbide. Once you press the carbide, it's gonna apply you depth of cut. It's gonna apply speed, and it's gonna apply the feed rate. So if you're what do you call it? If you're looking, if you got a lot of programming maybe, or if you have if you're owner of a shop or you have a novice guy, it's something you could probably set it up and input some pretty safe parameters. But like I said, it's everybody has their different styles and different needs, much different probably than mine. But I'm gonna make this as a different format. I'm gonna take this video home, and we're gonna be talking about everything. There's few things that will take a little bit longer. I'm at work, so I'm not supposed to use the camera. At home, I'm gonna explain everything, why you use certain things. This is gonna be a video more for a novice than somebody that understands all these things. But at least from the comments, I see there's a lot of people who are trying to get into machining, or maybe still looking for like getting these little details just to improve their craft. Okay guys, so I'll see. Welcome guys. So I'm gonna try to do a little bit different format. This is gonna be video technically for novice, for people that just started programming Mazatrol, for you to actually understanding the header and the end unit, because no matter what are you gonna program, the header, which is the top of the program, and the end of the program is going to have an effect. This is where your this is what Mazatrol reads. It's going to read the head, that's going to be your clearances, and also it's going to read the bottom. So I've recorded a video because the first thing when you open a, let me see something, when you open a Mazatrol, okay, is the material. So I've made a video and I'm going to explain. So technically The type of material is gonna have an effect on already pre-programmed feeds and speeds. I personally don't ever use them, but you can make certain adjustments, for example, because unless you're doing very similar parts all the time, then it's not gonna matter. You press the button, it's gonna fill up your cuts, your depth of cuts, and your feeds and speeds and such, right? Which might work, but sometimes we make small parts, big parts, long parts. Depends on your holding. You have a lot of holding. Sometimes you holding by very little. Obviously, you're not gonna go with crazy cuts because pretty much your part's gonna fill out of your holding. It doesn't matter if you hold in a chuck or using a collet system. So technically, no matter what you're gonna put, the material, like I said, I always put stainless steel. You can put aluminum. That's what that is for. So in a C condition page, you can look up the materials and whatnot, and you can make adjustments. But for me, technically, these things never work. It takes a fraction of a second to make the adjustments on the fly, and you're gonna get more comfortable with that. The longer you're gonna machine, right? Now, max OD. So, for example, I have a 2-inch part. I'm gonna put let's say 6 or 8 inches. I always go bigger. The thing is that if you have a 2-inch part, you cannot put 1.8 inches, for example, because, and I'll explain in a second. So I'll always go a little bit bigger or a lot bigger, and why? So max OD, what the machine does, this is where it picks up its clearances, right? So imagine, so this is gonna be your chuck, these are your jaws, okay, a little sucky, and let's say you have a part that's 2 inches. Okay, so the machine's gonna, so what happens, so you're gonna have a machine comes in, and let's say I have 6 inches here, right? It's gonna come to 6 inches plus, let's say 40,000 or whatever the standard for your machine is. If it's if you have 250, you're gonna have about 40,000. That's gonna give itself a clearance before it cuts. If you have a 350, then you're gonna have 80,000 and so on. Bigger the machine is, more clearances is gonna actually, by default, it comes to you. So what it does, it pretty much, it will come down to 6 inches, okay? Then it's gonna drop, and let's say if you say you're facing, let's say 2 inches, I'm gonna start my facing 2.1, right? I go about 100,000 higher, just in case if I make a mistake, you can still catch it. Instead of 2 inches, for example, and it will come down 1 inch, and let's say you made a mistake, or you have sometimes, you got 10 parts and you got one part that's extra long, so it doesn't come in and just shoves into the material. So I start 2.1, and if I see, let's say it's trying to remove too much material, I have a time to stop it. So the 6 inches, for example, on 2-inch part, all it does is just, like I said, it's just gonna come here, it's gonna stop at 6 inches, then it's gonna drop to 2.1, okay? And it depends on the face, and we're gonna get that, but let's call it, I put a 0 on the face, it's gonna come to 40,000. Then let's say if I'm removing 20,000, it's gonna come and let's say come down to 3,000, and then it's gonna face it, and it's gonna leave you the stock, whatever stock you set it up, let's say while writing a body of the program, the unit facing. So if you leave it at facing 3,000, you got 20,000 stock on the face, you do set it up to 20,000 cuts, per pass, you're gonna end up at 3,000. And then the machine's gonna retract, come up to 6 inches, and then head home. Now, where this is important is especially if you're using sometimes tailstock. If you're using a tailstock and it's supporting the part, obviously you're not going to face because you're gonna hit the tailstock, right? You're gonna hit the center. But for example, let me erase this. I gotta work on this board. But for example, you have a center here, right? This is the body of the tailstock. Let's say your tailstock is 6 inches. Okay, and you're doing OD turning, right? So like it OD turns over here, for example, and then you coming down, and then you it just does removes the chamfer, and then if your OD max is set to inches, she will crush into the tailstock, right? Because she's gonna go head home straight. But if, let's say, your max OD is set to 6 inches, she will throw the chamfer in, she will come up to 6 inches, and then she will go home. So technically, that max OD is telling the machine that you have a 6-inch part to go 6 inches or above before to head home. This is why I just kind of made this a habit of mine to go higher, because it doesn't cost you anything. Gives you a little peace of mind that the machine is gonna retract, it's gonna go up, and then it's gonna go, let's say, to the longest tool or whatever you're gonna set it. The only time where I use, for example, if I have a 2-inch part, and on some things it does it, okay, I got 2-inch part, and let's say you do milling, you do a lot of holes and whatnot. Well, so for example, you have 10 holes, you mill, and that's gonna be in 1 unit, right? So you go 1 unit, for example, 6 holes, and then you divide your 360 by 6 holes. This is gonna be angle, and it's gonna rotate that angle, and then it's gonna come down. Then what's gonna happen is, let's say the part is 2 inches, like previously stated, okay? So the machine comes down, it's gonna hit that hole, then it's gonna go 6 inches up, it will rotate, it's gonna come down. Then it's gonna do this hole, it will go 6 inches, rotate, and it comes down. When you have a lot of, for example, a lot of features, then it makes no sense for you to actually set it to 6 inches, because now you're wasting a lot of time just on the travel up and down. So in some instances where that happens, just as a time saving, especially if you're doing production, then yes, I will, let's say if I got a 2 inches, I'm gonna set my max OD to, let's say, 2.1 or 2.2, a little bit bigger. So that means that in that case particularly, it will only go 200,000 higher. It will rotate and then come down, right? That's how you save time on the travel itself. Same thing is when you're milling, for example, close to the jaws, and you see, this is, I do that sometimes, especially if, for example, you have a feature that's gonna look like this. So you have a part, right? You have your jaws here. And then let's say I got 3 holes, and I'm gonna be drilling those holes, unfortunately, very close to the jaws, right? So I'm gonna have to set my C. So I'm gonna set my C where the tool comes here, drills, pulls out, it's gonna rotate, and it's gonna hit this one and this one. So there, for clearance sometimes, for example, if you're going right in between the jaws, if you only retract a little bit, and then you have that jaw rotation, and it's gonna hit your holder, if you tell her your material is, for example, 8 or 10 inches, it will retract far enough to where it rotates, and then you come back and you go between jaws, right? You finish this feature, you go up, it rotates, then you come up. So this is why setting up the material size is important. So technically you use it for clearance moves, tailstock, milling, and other things. Like this is it's a case that I use fairly often, and like I said, unless I'm worth, machining a particular case where there's a lot of movements and retracts, and that's wasting time, then I'll do that. Okay, so this is gonna be your max OD. So if you don't have a problem with clearances, you got a 2-inch part, set it to 2 inches and 200,000, for example. But outside of that, like I said, give yourself an extra room, especially even a beginner, because it will always give you a little bit extra time if you mess up your program, your, whatever, to see that like she's coming out a little bit too close or past the part and whatnot. Like everybody goes through this eventually. Now, when it comes to your ID, okay, so my ID, it doesn't matter if I already have a hole 2 inches or 3 inches and whatnot, I always set it to 0. For the fact is that if you do have, for example, you got a, part, you have a 2-inch hole, you're gonna tell her to start cutting at 2 inches. She will not come down to 0 if your minimum ID is 0. She'll only retract, let's say 40,000, then it's gonna come out and go home. So it's not, so the clearance on ID does not reflect necessarily the ID. That's why it doesn't matter if I have a hole or not, I always use a 0 anyway. Now face, this is actually a fairly important feature. So the machine's telling you how much stock you have on a face. And I use this a lot. On average, I give myself at least 200,000. So for example, I got a face of the part. I'm trying to remove, let's say 40,000 off the face, right? So between here and here, I got 40,000. And I'm still gonna, let's say, set my face to 0.2. So the machine's gonna come, she's gonna stop 200,000 from the 0 that you set on the face. Then she's coming down to 40,000. Let's say you're removing 20,000 on each pass, so it's gonna come down to like 20,000 plus. It's gonna face, right, to center, retract, come down. Then it's gonna come down to 3,000, retract, and then it's gonna go home. But imagine sometimes when you do a lot of shaft work, right? And for example, there's center is not allowed, but you have an extra stock, let's call it 300,000 for the center, that once you're done machining the part, you're gonna remove that center. And you have a blueprint. On the blueprint, you had a lot of features and stuff like that. So let's call it 300. If I got a 300,000 center, extra stock for the center, I'm gonna put on my face 0.300. And let's call it that this is gonna be the part, all right? Let's stick to that 2 inches. It's gonna come down here. I'm gonna leave this center, 0.300 on X, and then half an inch here, right? Okay, so 300, 300. So what you can do is you can touch this off, set this as a minus 300, so the machine automatically is gonna set this section where we want it as a 300, right? And then you go, let's say you do OD turning, so you go bar out, your cutting position, your starting position on X is gonna be 2 inches. Your starting cutting position on a Z is gonna be minus 300, right? When we program, and this is our 0, the way we program, remember we program everything in the positive here. We program from a 0 that's set everything in negative here, okay? There's a sense because technically most of the program you're gonna go towards the left side. I think it was a really great idea on Mazak part that we don't have to put minuses each time, especially if you have a lot of units, a lot of programs, a lot of lines. It's just, it's not necessary, and I've had a problem where I had to program Siemens control and I had to keep pressing minuses on everything. It's just, it saves you a lot of time, and like I said, I mean, I think I'm really happy that Mazak went actually that way. But you have to remember, so when you program, so let's say we're gonna tell we're starting from minus 300, so the machine's gonna come down here, right? And it's gonna start machining from the 300 down to 0, and then let's say you can run with your program. So let's say you programming here, you got your lines and maybe your grooves and your tapers or radiuses or whatever. You don't have to take that 300 stock to set it 0 and then just add 300 to pretty much all these features that you have, because you can go from minus 300, okay, do like a line, your finishing line on a Z is gonna be a 0, and then you start another line and let's say 2 inches, and then you do all your features or whatever you're turning like as you normally would. So like I said, you can follow the blueprint with all the dimensions and your lanes and your Z's and your X's, where this is kind of left alone. So once you're done, you can just touch this off, you know, call it 300 and then pretty much face it off later. So this is where you're telling the machine you have 300,000 stuck on your face. Another thing is that sometimes, for example, if you have a center, but you have to go very, very low, you can actually, let me see, but you got to be really careful. And on this one, you have to go in your TPC and change the clearance move. And let me explain why. So we got 2 inches. So you can do this. Let's say a lot of times you got this taper, right? And then this taper would leave you very little, very slim stock for your center. So what you do is you can, let's say, go half an inch here and then taper off and do this. Okay, kind of looks like this, right? And so technically this will be your 0, but you have this section where you come in and this is your center. So you tell your machine, for example, you know, 1 inch, go here, then go, you know, you can use a 35-degree tool. You can do like -50 taper, right? It will calculate for you your finishing point Z, and then go a little bit straight, go to 0, and then, you know, throw that big chamfer over here and just continue. The thing is that for some reason, when you go from -300 down to 0, and I usually do this feature only by itself, the machine will come down here and retracts into the material. Okay, so what you have to do is you have to go to TPC, and when you see escape, you have to change your escape, let's say to X 10 inches and Z 20,000. So that way the machine will come down here, right? Come down here. It's gonna run this finish here, then retract to 20,000 and go to 8 inches. This is the only, well, there's these two, I have these two situations where usually I have to use the TPC or the machine technically does not. I don't know why it does this, but be careful. So when you work with stuff like that, you know, go to toolpath or go to trace, and if your machine's gonna show you it's doing here and it's cutting here, she will follow exactly what she does on a toolpath. There's no doubt about it. It's not a glitch. Okay, so don't run the machine. Well, if you're gonna run it dry where it's not cutting the part and see how it's gonna behave. If it's gonna come out, you just save yourself a little crash, right? Or some destroyed material. So this is gonna be your kind of, you know, working phase. So your working phase is technically how much stock you're removing from the face. So if you got 200,000 stock, put 200, right? If you have, for example, if you have 20,000 stock, you can also put 200. It will always give you that clearance. And the clearance is one of the most important things. Like Mazak is amazing when it comes to calculating, you know, approaches and escapes. But sometimes, occasionally, they might be like similar case when you're gonna be in a really tight spot, which will benefit to just have a little bit extra room. Because, like I said, once you learn the way that Mazak works, and if it's approaching and it's not approaching like it's supposed to, there's a mistake you've made, and I guarantee you, it's not the problem with the machine; it's the problem within the program. And then your RPMs are, you know, depends on the collet. It obviously depends on the size of the chuck you carry. You know, if it's what do you call it? If it's a 10-inch chuck, you know, you can run the 1200, 1500, 2000. Depends on the size of the parts, the size of the holding, the weight of the parts. The bigger you're gonna go, the lower the max RPM. So if you put 12, let's say 1200, this is the max RPM that will do once you're in the center of the part. So material, max OD, you know, clearance, retract. So like I said, if it's a lot of up and downs, then I would just short it to the size of the part. Max ID, always put as a 0. Phase, like I said, if you have a stock, you know, this is where you usually put. If you need to leave a little bit, like I said, a little extra material for the center, you know, then this is where you do those things, and pretty much that would be it. Now, when it comes to the end, so this is where if you do, for example, like you know, repeating parts, or you have one program that jumps in another program. If you're shifting parts, for example, this is where that's gonna be. This is where you're gonna include all that in end. So as far as the end unit, so technically every time your machine's gonna go through to a program, or if you're gonna run even what do you call it, trace, right, or toolpath, she'll always look at the end. So if you, let's say for example you have 10 units, if you're gonna run first unit, second unit, for example, only a single block is just gonna run that unit. She's gonna search for end. If you're gonna run everything in auto, she's gonna she's gonna look for the end. So there's two ways to obviously write a program, right? Like I do, the way I do is like I fill up the header, and then I fill up the end unit, and then I start to add my body. So I add my facing, my OD turning, my threading, drilling, whatever that is. The reason I do that, because for example, if I want to add face, okay, then I want to do OD turning, and for example I have some weird radius and I want to trace it, right? I want to see how it looks. If I don't have that end, she's not going to draw it for me, because she's going to look for that end pretty much. So that's how I do it, and I just keep inserting, unless you want to write the whole program and then throw in the end and then go back to trace and see how your part looks. If everything looks good, then you can continue, you know, you can run it. And unless there's some sort of an error, then, you know, she's gonna run everything and pretty much it's gonna go to the end. That's why I start with the end. So continue, this is where if you have one part, for example, as it continues, like do you wanna continue the machining? Normally, if you just run one part, you know, all the units, you have slugs or whatever, then you're gonna press no. If, for example, and I do this often, so let's say I have a slug, all right, let's call it 10 inches. And so that's be 10 inches. And what I'm doing, you know what, actually I'll make it more simpler. I'm gonna call it, so this whole slug is 5 inches from my chuck, right? That's how far it's sticking out. This is my clearance. And I have 5 washers. So let's say my washers, and I can get 5 washers out of this, right? So that means each washer would have to be 1 inch, no bigger than that. You know, minus the cutoff. So let's say my cutoff is 120,000. So that means my washer is, and we're not worried about the extra stock for the phase and whatnot. It's gonna be 1 inch minus 120, right? So that means my washer would be 880,000. So what happens is, so I'm gonna say, yes, I want to continue. From what I remember, the continue is 1. I don't wanna continue is 0, right? So I wanna continue. And it's gonna say, do you repeat? How many times do you repeat, right? So if I got 5 washers, I'm gonna say repeat 5 times, okay? And then it's gonna say shift. And let's say since 5 washers with my cutoff, and the ring's gonna be, let's say 1 inch. So technically 880 plus the cutoff, that's gonna be 1 inch. My shift is gonna be 1 inch. So what the machine's gonna do is gonna come, so let's say, you know, you do 1, you do OD turning, you do facing, you know, maybe you do drilling, you know, you throw a chamfer here, throw a chamfer here, and all these things, you're gonna come up with a cutoff, boom, 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 the part falls off, right? Then automatically this becomes your 0, and the machine shifts that 1 inch, right? Now we making the same thing over here, and making the same thing over here, making the same thing over here. So technically what it does, it's gonna repeat the same thing 5 times. If there are small washers, you might use a parts catcher. Sometimes you can just have like some sort of a plastic basket you can put on the bottom. usually the washers will fall. If it's a bigger washer, for example, or and whatnot, like this is what I do. This is like my trick, for example. I'm gonna add this. So look, if you have a part that's not really too heavy, okay, and I'm gonna cut it off. On average, let's say this is my part, okay. This is the bar. So actually, this is a horrible visual, right? So this is my part, okay. I'm gonna try to cut, and this is actually a bar. So I machine this, whatever, and then I wanna cut this off here. I'm gonna cut this off, depends on the size, and leave anywhere for small parts. If you leave 100,000 stock, the cutoff comes by, you can come off and you literally break off the piece. Right, and it doesn't matter how it looks. I mean, it can look like this. Once you break it off, you're gonna have this little nipple, so you can grab it here or here and then machine it off, right? Or you can, if you don't wanna like machine off and you can, you know, get away with it, you can probably grind the back of it and just lap it. But if you have a ring, for example, and it's got a hole in it, and let's say that the hole is gonna be 1 inch, okay. Then I'm gonna come down, I'm actually gonna cut it off. So this is gonna be my cutoff, okay. And there's that hole over here. You usually drill it a little bit past, or you drill it pretty close. If your hole is 1 inch, and with the cutoff you're gonna come to 1 inch, it's not gonna break off. Because what usually happens, that cutoff creates this little bit, you know, the kind of dent in the part. So we'll push that material a little bit off, right? Because there's nothing holding it in. And then you can come and you can use like a rubber mallet, and you can hit it where it's gonna go inside and actually fall off. On average, if my ring is 1 inch, I can go about 10 or even 15,000 below that hole, and sometimes it might not even fall off, or it's gonna be barely there. So this is like a really good way where, for example, you know, so if you do this, you machine, and at starting unit, because it's gonna do this. It's gonna read the program, go to the end, repeat, right? Read the program again, repeat till, you know, to repeats 5 times. So usually what I do, if I'm gonna have to hit it and, you know, or remove it or break off the part, I'm gonna go to my facing, and where you have your, at the end, you have your M codes, right? So you're gonna put where you usually put M8. You can put M0 for a stop, or M1 for an optional stop, but then you have to press the optional stop. So she will come down here, let's say she'll cut down, she's gonna, you know, she's gonna cut off that ring, but it's still gonna be sitting. Then it's gonna retract. Then you're gonna have the shift of the turret to start and repeat this one. But since I have an M0 there, it's gonna wait for me to press the start. So I'm gonna come in, I'm gonna hit this part with the hammer. Okay, I'm gonna grab the part, and then I'll press the start, and now it's gonna repeat the cycle. So this is one of the those things. Is like, how do you you know, continue, and how much you are repeating, and how much is gonna shift. Now this is very important, and I had this happen to me like 2 years ago. I couldn't figure out for hell what's going on. I actually had to call Mazak, and and they actually, one of the application engineers, they figured out what happened. So usually when you set, there's also maximum length of the part. How long is your part, right? So I figured, for example, you know, my part was 1 inch. I was doing, let's say five parts, right? So it's 5 total. But I'm like, since the part is 1 inch, I'm just gonna put it as a 4 inches, right? So this was my mistake. Everything was running good, but for some reason on the last part, and my part looked like this, right? So I was doing a ring job. So like I said, out of big bar. So let's do this. So I did OD turning, so facing, OD turning, right? Then I would come with the drill, And then I would come in with a 35-degree bar, throw in the chamfer, finish the bore, and then I would do a chamfer in the back. So for some reason, only on the last piece, it would cut that back chamfer, come out, run the finish, and come inside of the material, and it will keep breaking my inserts. And I mean, and I tried to, you know, go to TPC and do clearances and all these things, and nothing worked. And technically the problem was that the length of the part, if you're cutting 5 parts, you have to give the parts that are accumulated, so 5 inches, and add always an extra, okay? The problem was that, let's say, you know, my total material length was, like I said, it was 4 inches, but the actual accumulated was 5 inches. And that 1 inch kind of messed up the clearances. And it was weird because I would get 4 good parts. My 5th part, you know, like I said, it didn't work. So always add all those together and give yourself a little bit extra room. So this is kind of shift. The number continue, that's gonna be, you know, if you're doing 1,000 parts, for example, and you have a lot of them, then you can press 1 that you want the machine to you know, each time it's gonna hit the end, it's gonna calculate how many pieces you already done, and then return. So return, I always go to the longest tool, right? So for example, if this is your turret, this is your part, this is your 0, this is your turret, for example, and this is your, let's see, longest tool, right? It's gonna be a drill. So well, it's an ugly drill, but it's a drill. So what the machine is gonna do is let's say it drills over here. It's gonna come down to, let's say if you have a face of 300, it's gonna pull out 300,000. It's gonna come up, and then, you know, come up to the longest tool, which is gonna be the drill, for example, plus the, you know, 300, and then it's gonna rotate, and then it's gonna come down, and then it's gonna engage another tool. So this is, you can also set it to 0, or you can set it to arbitrary, right? So usually these are clearances, but I've actually never used it to the longest tool. It always worked for me, and I haven't had a really like a situation when that was not, what do you call it, when that was not sufficient. So this is, like I said, this is very important. You can play with those things, and like I said, you know, so the top is gonna be your clearances. The end pretty much is gonna be, like I said, this is good for your, you know, repeat parts and such. Like for example, I've used this before too, and that was on the video that I did on the sprocket, where I had you can do this with grooves and such thing. And so like I had let's say for example, you got a part, and imagine you can have a sprocket or a bunch of holes or whatever, right? So you're gonna drill here, the blah blah blah, whatever, and then instead of copying, but this only has to be pretended to that one particular unit. So instead of, you know, setting another unit, another unit, another unit, another unit, you can just do that particular feature in one program, right? So you do everything here, and same thing is, so you do, let's say drill, you're gonna drill, let's say, and this only works if all these spaces are equal. So let's call it, right, 1 inch, 1 inch, and you can have 5, 20, 30 of them, whatever, right? So you write a unit that's gonna be drilling, for example, using live tooling, and let's say, you know, the start is gonna be 0.5 inches from the face. So your Z is gonna be, let's say 0.5 inches, your starting point, and then you're gonna finish. Then she's gonna read to repeat 5 times, and you're gonna shift 1 inch. It's same thing, it's gonna shift 1 inch, it's gonna drill all these holes, come up, shift again 1 inch, right? Go up and continue. So same thing for turning, milling. Sometimes, like for example, you know, the grooving, especially, it's like if it's like I don't know why Mazak can't do that. Like this is one thing when it comes to the grooving where I've been having issues. Is for example, I have a groove that's got like crazy radiuses and whatnot, right? So if you program them as a groove, and you throw in big radiuses here and there, sometimes it does this. It just can't read it. So in situations like that, for example, I'll have to come in with the OD turning tool, and I'll create, you know, radius into a radius, into a radius, into a radius, right? And then I take a grooving tool, I set it as a general tool, I set my angles as a 0. So angles as a 0, it will allow the, you know, the Mazak to pretty much kind of go down, and I just do it in this feature. And then the finish comes in and it finishes that, right? And for example, I got 50 grooves like that, and my grooves are spaced apart 200,000. So I can tell the machine continue, yes, repeat. If I have 50 grooves, if I got, you know, they space every 200, shift 200, and same thing is, so this feature is very, it's very useful. Like I said, I use it a lot on a lot of things, and it just keeps, you know, the machining and everything, what do you call it, fairly simple. Like I said, if sometimes, you know, when you look at the program, you made a program and you don't remember exactly why did you program it, just add comment to it. If you use M2 for, you know, for knocking off or breaking parts so your machine doesn't come and plunge into the part you already machined, make a note that when you run this part, press optional stop, so it's gonna read that M1 if you don't know, if you don't wanna use M0, for example, right? And yeah, so this is your header and end unit. So whatever you're gonna put in your body, these two things are very important. So thank you guys for watching. I hope this is fairly visible. And like I said, I'm gonna try to kind of improve a little bit, you know, in my free time where I'm not at work. I don't have to worry about my boss coming on me, and try to be a little bit more clear. So like I said, you know, the base of the program is pretty much how to start it, right? And how to end it. All right, guys, thank you.